Okay, you're welcome to the class of Physics 202. This is modern physics that talks about, modern physics is basically into two. We have the relativity and quantum physics. So this is some kind of quantum physics. So the first thing we're talking about is an atom. What is an atom? Assume I'm having a yam here, a piece of yam, a tuber of yam. I'm gonna slice it, cut it into half. This is the tuber of yam. Cut it into half, quarter, then 1/4 is taken out of it. Cut this 1/4 into 100 slices, like this. Now, take one of the slices, cut it into 100 slices again, smaller slices. Take those slices again, cut it into smaller slices, then take those ones, keep cutting until it is uncuttable. So the last uncuttable piece is what we call atom, and that is seldom seen with the normal eye. An atom is the smallest indivisible part of an element that can take part in a chemical reaction and still retain the chemical properties of that element. That is what we call an atom. So what is the structure of an atom? What does an atom look like? An atom is spherical in shape. According to the last model that explains, the most sound model of atom, it is spherical in shape that has a positive center called nucleus. This is an atom. This is the nucleus of that atom, inside which we have positive charges. This plus means positive charge and some other chargeless particle. The positively charged particle here is called the proton. The proton, that is an atom. I'm assuming I'm going to say I have a sodium atom. Sodium is Na with the atomic number of 11. Atomic number means the proton number. That means the sodium atom is having 11 proton in itself. We are looking at the structure of the atom now. So it has a positively charged particle in it, that is the proton, and a chargeless particle as well, which is the neutron. So it also has negatively charged particles orbiting around the nucleus. We call the negatively charged particle electron. Electron will be orbiting around the nucleus in specific orbits, depending on the energy level. So it is negatively charged. Electron is negatively charged. So it is what? Electron. So you see the proton, neutron, proton, proton, electron, and neutron. I said the proton is positively charged, electron is negatively charged, and the neutron is what? Chargeless. The three constitutes the subatomic particle. Because of the scope of this course, I won't want to go too far, or else I would have liked to bring about the fact that we said atom is indivisible, and at the end of the day we're still saying atom is containing something. What is indivisible should not be having subparticles. Yes, but perhaps you'll get to know that in the models of atom. So the atom is having proton. The proton is a positive charge with a mass of plus 1.2. Sorry, mass, it doesn't have any charge, any sign. 1.675 times 10 raised to power minus 27 kilogram. That is the mass of the proton. And the mass of the neutron is equal to, approximately the same thing as the proton. 1.673 times 10 raised to power minus 27 kilogram as well. While the mass of the electron is 1 upon 1084 times this mass, which is about 1.9, times 10 raised to power minus 31 kilograms. That is the mass of an electron. So these three things are the subatomic particles. They are found in all atoms except hydrogen, which doesn't have neutron. So I'm going to be illustrating this with the sodium atom Na, and I would like you to know that in the nucleus of the atom, a force that exists there is known as the nuclear force. The nuclear force exists in the nucleus of the atom. That is the force that binds the proton and the neutron together. That is the nuclear force. The force that binds the electron together with the nucleus, that's making the electron to still be with the nucleus, is known as the electrostatic force, which is the normal Coulomb's force of the magnitude F equals kq1 q2 upon the square of the magnitude of the distance that separates them. And k is equal to 1 over 4 pi, the permittivity of free space, which is 8.89 times 10 raised to the power of 9, and the unit is what it is, I suppose, Newton meter squared per coulomb square. Yeah, that is the unit. So this is a quick introduction to an atom, to what an atom is. So let's try to illustrate with a sodium atom. So a sodium atom is an atom with the atomic number 11 and the mass number 23. This is how it is written: atomic number 11, mass number 23. So I'm going to write that the first, or K shell, this is a shell, this is the nucleus, L shell. So the first shell will contain 2 electrons. That is by obeying a principle we call the Aufbau's principle. The next shell is L, and the next shell is M. So this is 11 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is sodium. This sodium is having 11 electrons. It is having 11 protons. But it is not having 11 neutrons because this is the nucleus of the atom. And the nucleus is going to be the what? Proton plus neutron. You know, that is obvious because the proton and the neutron are inside the nucleus. So if the mass of the element is 23, is equal to the proton is the same as electron since it's an atom. So 11 plus neutron n equals 23 minus 11, which is 12. Hence, the atom sodium is having 12 neutrons. It is having 12 neutrons and it has 11 protons. So that is that about this. And in the next thing, I suppose we should just continue and talk about atomic spectrum that has been talked about. Charge quantization. Charge quantization. So when I say charge quantization, in all atoms, there are charges. What are the charges? Protons and electrons. They are opposite charges. Protons are positively charged and electrons are negatively charged. So charge quantization is telling us that it is a principle that explains that the smallest charge that could ever exist in the universe is the charge of a proton or the charge of an electron, with the magnitude for a proton E equals plus 1.6 times 10 raised to the power of minus 12 coulombs. And for electron, E equals minus 1.6 times 10 raised to the power of minus 12 coulombs. Plus is for proton, minus is for electron. This is the smallest charge that could exist in the universe. If something like this exists, then all other charges that constitute electricity, that makes up anything, any charged particle, the principle of quantization of charge says that any charged particle is going to be an integral multiple of the charge of an electron. That means all charged particles will be n times e, where n are integers, whole numbers that are not decimal. So I can say, let's assume I have an iron rod that is having charge in it. The charge can be 3.2 times 10 raised to the power of minus 12. So 3.2 is what? 2 times 1.6 times 10 raised to the power minus 12. So n is 2. What we're saying is that n must be equal to 1, 2, 3 to infinity. We can never have continuous values. It should be discrete. It should be discrete. Sorry. Oh, I seem to have been confused about the spelling. It should be discrete, and that is like I shouldn't have a charge. This is an element that's having a particular charge, or this is a particular charge, and the charge is now 1.2 E or 3.5 E. It will rather be 1 E, 3 E, or 4 E. No point at all. No continuous values, only discrete values. No point. It moves from 1 to 2, from 2 to 3, from 3 to 4, 4 to 5. No intermediary between the energy levels. Thank you.